Hey guys, welcome to Tech Learnings. Today we are starting up with data structures and algorithms series. Now this topic is one of the most frequently asked in top companies interviews. As computer engineers, this is like considered to be the basics that everybody must be aware of. And still, including me, it's one of the toughest questions to answer in interviews as well. So the purpose behind this series is I'm not an expert, let me tell you, I'm not an expert in data structures and algorithms, but whatever I know or basically I want to share with you guys, and in the process if I also get to learn few new things, let's say, so then I would rather be very happy. So let's try to grow ourselves in data structures and algorithms. So this is the whole purpose behind this series. So today the topic which we are going to discuss is time complexity, because this is something which we are going to frequently uh, use in when we study further different algorithms, right? So we know that performance of algorithms is basically determined in two terms. It's a space complexity and time complexity. So today basically the focus of this session is on time complexity. So how do we represent time complexity of algorithms? What we exactly mean by them? If I write, let's say, order of n, then what do we mean by that? If I say order of log n, what do we mean by that? So let's clear first these basic things so that we do not have any problems in the further sessions. Okay, so time complexity is basically represented in the notation that we use. We call it as big O notation. So big O notation is used to represent the uh, time complexity of any algorithm. Okay, so let's see what all different representations that we have. So one is order of one. First is order of one. So when we say order of one as a runtime complexity of any algorithm, we mean it's a constant basically. The time is constant. So it is not depending upon the input. Okay, input size to be precise. So if your means let's say your input is containing 10 elements, it is containing 100 elements, it is containing 1000, 1 lakh, 1 million. So the order uh, one means the time is going to remain constant. Okay, for example, I would say that adding a node to the tail of a linked list, so that will be in order of 1 always, right? Now when I say order of n, now here it means we can call it as linear, means that the time complexity is dependent upon the input size. Okay, so it's directly proportionate to the input, we can say. So if our input is let's say is 5, containing 5, then our time complexity will be also linearly proportional to that order of 5, we can say. If 6, then order of 6. If there are 100 elements, then order of 100. If there are n elements, then we would say order of n. Okay, so this is we mean by order of n, linear basically. Now let's say order of n square. So I don't have any way to write the square in notepad, so consider it not as n2, it is n square. So order of n square is basically, you can call it as the term is quadratic. So it's a quadratic, like we have in mathematics quadratic equations. So n square, like we'll study further. Basically selection sort, or if you have heard of this studied of these algorithms like bubble sort, they have order of n square. I tell you what is n square means, that suppose there are n elements. Okay, so for each element you are means iterating through your input again n number of times. Okay, If you are not getting this means very clearly, then no problem. When we study those algorithms, like I mentioned, selection sort or your insertion sort, so this will be clear to you that what exactly we mean by when I'm saying that iterating for each of the element, and for each of the element you are iterating through your input again n number of times. For now, just remember that order of n square, we mean that it is quadratic. Now order of log n, this is also we frequently use. So what is order of log n is this is the time complexity of algorithms where basically we are dividing our input into, let's say, halves. Okay, so just for example, binary search, if you have an idea of that, so every time we are dividing our input into halves, so such algorithms are going to have the time complexity of log n. Okay, so now what about order of n log n? Let's say order of n log n. Now what is order of n log n? Again, dividing into halves, or in fact we should not say halves, we should say smaller parts. Our input, we divide it into smaller parts or smaller chunks, you can say. Then that smaller chunk we again divide it into more smaller chunk, then we again divide into more smaller chunk, and then we combine the output of those, each of those steps, each of those means divisions, you can say. We divided, okay, we get some result. Again divided, we get some result. We again divided, we get some result. Then after that we combine all those results to get our final answer, to final. So such algorithms basically, they do have time complexity of n log n. Okay, for example, we'll study, like I said, quicksort is one such example. So order of 1, order of n linear, order of n square is quadratic, and we can call it logarithmic, and it is n into logarithmic, right? So this is these are the different time complexities that we have. Order of n, like n cube, we usually do not have actually. I never saw any algorithm, in fact, which had this order of n cube as time complexity. So far I think this is enough for us, that if we know these time complexities, order of 1 means constant, order of n means linear, means directly proportional to the input size, order of n square is your quadratic, order of log n, which is logarithmic, usually we have when we divide our input into smaller chunks at each step of our algorithm, and order of n log n, it's similar to log n, that we are dividing our input into smaller pieces, smaller chunks, and then we are combining the output or result of each of those steps, you can say, to get our final output. Okay, so this is about the time complexity. I hope I could clarify these things and you got it as well. So thank you so much for watching this video. We are going to learn a lot of things, so stay subscribed and stay tuned. Let me know if you have any questions, any doubts. So let's learn together. Thank you.